This technical demonstration will show you how to install and configure PowerChute Network Shutdown for a VMware environment. First, we will show how to install PowerChute on a Windows OS. Right-click on the downloaded setup executable and select Run as Administrator. On the welcome screen, click Next. Review the license agreement and click I agree to continue. Choose the option Enable VMware Support and click Next. Enter the destination folder and click Next. Enter the user credentials that will be used to access the PowerChute UI. This prevents unauthorized users from accessing the setup wizard after installation. Click Next. Click Install to proceed with the installation. Click Finish to complete the installation. You can then launch the setup wizard to configure PowerChute step by step. You can also deploy PowerChute as a virtual machine running within your VMware environment. This is the preferred option in most use cases, except for environments such as Nutanix, where PowerChute cannot be deployed within the cluster. We will now show you how to deploy PowerChute using the vSphere OVF deployment wizard. Having logged into vCenter, right-click on the cluster containing the host you want to protect and select Deploy OVF Template. Select Local File and then click Upload Files. Browse to the location where you downloaded the PowerChute OVA file, select it and click Open. Click Next. Enter a name for your PowerChute VM, select the location and click Next. Select a compute resource and click Next. This may be the cluster or an individual host. Click Next. Review the license agreement and accept it to proceed. Select the storage location and click Next. This may be a local data store or cluster storage depending on your environment. Choose a destination network and click Next. This will typically be the same network used by the user VMs. Customize Template allows you to configure network settings for the PowerChute VM. It is recommended to use a static IP address. Enter a root password that can be used to access the PowerChute VM via the VMware console or SSH. Enable SSH access if required. This is typically only needed to gather log files for troubleshooting. Set your preferred time zone. This determines the timestamp that will be used for the event log. Enter the username and password that will be used to access the PowerChute UI. This prevents unauthorized users from accessing the setup wizard after the appliance is powered on for the first time. Please note the password complexity requirements. If the password entered does not meet these, the PowerChute service will be disabled for added security. Click Next. Click Finish to start the OVA deployment. Select the cluster, click Monitor, and select Tasks to view the deployment progress. When the deployment task completes, select the PowerChute VM and click the Power On button. Launch the web console to view the URL that is used to access the PowerChute Setup Wizard. We will now show you how to use the Setup Wizard to complete the configuration. In your preferred browser, enter the PowerChute URL. Enter the username and passwords that were set during the installation. On the welcome screen, click Next. The Customer Experience Improvement Program helps us to improve our products and services by collecting anonymous usage and configuration data. Click Next. Select IPv4 and click Next. Choose Host Managed by vCenter Server and click Next. PowerChute requires a license to avail of advanced virtualization features and support. If you do not have an internet connection, you can use the offline method to activate. Otherwise, choose online. You will have received your activation ID via email from your partner or via Schneider Exchange. Copy and enter your activation ID in the field provided. In the quantity field, enter the number of virtualization hosts you wish to protect. In this case, we have 3 nodes in the cluster, so 3 licenses are needed. This is one activation ID with a quantity of 3. Click the Activate button. The PowerChute license has been successfully activated. Click Next to continue. Enter your vCenter server details. The user account entered here should also exist on each ESXi host, so that PowerChute can connect directly to the hosts in the event that vCenter server is unavailable when a power outage occurs. In this case, vCenter is deployed as a VM, so we enable this checkbox. Choose the appropriate HCI environment from this drop-down list, or leave it as none if you're not using any HCI technology. Click Next. PowerChute will attempt to connect to vCenter server using HTTPS. For enhanced security, PowerChute presents the SSL certificate used by vCenter server. Verify and accept the certificate in order to proceed. PowerChute will not connect to any system over HTTPS unless the SSL certificates have been added to the PowerChute key store. Click Next after adding the SSL certificate. PowerChute supports a range of UPS configuration options. For this demo, we will choose the redundant UPS configuration. Enter your security details. The username and password are used to log into the PowerChute UI. The username and authentication phrase are used to authenticate with the network management cards. Add the IP addresses of the network management cards to the UPSs being used to provide redundant power protection. Click Next to continue. Confirm the details and click Apply to register PowerChute with the network management cards. The connection fails because the NMCs are using self-signed certificates and are therefore untrusted. Click the Fix Issues button. The certificate management screen allows you to view and verify the SSL certificate details for each NMC. After adding the certificates to the PowerChute key store, click Next to proceed. Click Next and apply settings to complete the registration process with the NMCs. PowerChute has successfully registered with each NMC. Click Next. On the host protection page, select all of the nodes that you wish to protect. If PowerChute is deployed as a VM, it will automatically add all nodes in the same cluster where it is located. Click Next. On the Host Certificate Management screen, verify and add each of the vSphere Trusted Root CA certificates. This is necessary so that PowerChute can connect directly to the ESXi hosts if required. Click Next. If your UPS supports outlet groups, select the one that is supplying power to your equipment and then click Apply. Click Next. The Virtualization Settings page allows you to define the time needed for each step in the virtualization shutdown sequence. We now support handling vSphere Cluster Services, or VCLS, during the shutdown and startup process. VMware High Availability can now also be disabled as part of the shutdown sequence. Click Next to apply the settings. Confirm your settings and click Next. We recommend enabling the option to turn off the UPS after the shutdown completes. This helps prolong the UPS battery life rather than letting the battery drain completely each time there is a power outage. Click Next. Click Finish to complete the setup. We will now review the UI changes that have been added in PowerChute v5.0 to enhance usability. The UI now uses a horizontal tab menu to group features. Under Home, select View Event Log to pinpoint when issues occurred. The Configure Events page allows you to define which UPS events will trigger a shutdown sequence. For example, UPS on battery power for 5 minutes. The Communication Settings page allows you to view and edit your vCenter server settings. It also validates the vCenter server communication when the page is loaded. You can also modify your PowerChute security details. The Check Details button verifies that authentication with the NMCs is working as expected. On the Shutdown Settings page, you can configure a command file or script to run during the shutdown. The SSH Settings page allows you to configure SSH actions. These can be used to run commands on remote systems such as the storage array via SSH. You can configure multiple SSH actions and have them run during the shutdown or startup sequence. The SSH command file is a text file containing a list of commands to run in sequence on the remote system. This must be stored in the user files folder where PowerChute is installed for security reasons. The SNMP settings page can be used to enable SNMP access to PowerChute. SNMP v1 and v3 are both supported. For security reasons, we recommend only using SNMP v3 and using SHA 256 and AES 256 for authentication and encryption. PowerChute can also be configured to send SNMP traps when communication is lost or when a shutdown is triggered. The virtualization settings page allows you to fine-tune your shutdown and startup durations. The VM prioritization page allows you to control the order that your VMs are migrated, shut down, and powered on. To do this, select the VMs from the inventory list on the left and drag them to a priority group on the right. Then set appropriate durations for each priority group. High priority VMs are shut down last and powered on first. Under UPS configuration, you can find details about the network management card. There is also a button to launch the NMC UI. The PowerChute Agents page lists the IP addresses of other agents that are registered on the same NMCs. PowerChute automatically checks for software updates every 7 days. This can also be done on demand on the Update Settings page. The licensing page provides details about the renewal date for your license. It also provides an option to return the license. If you intend to redeploy PowerChute on a different machine or use a new version of the virtual appliance, you must return the license before uninstalling or deleting the old appliance. We will now showcase PowerChute in action protecting a VMware vSAN cluster. VM prioritization has been enabled and VMs have been added to priority groups. VM migration is disabled since the entire cluster will be shut down. Shutdown and startup durations have been added to the priority groups. Note for Group 1, I have set the startup duration to 0 seconds. This means that low priority VMs in that group will not be automatically powered on during startup. The UPS has been running on battery power for the configured duration. This triggers the shutdown sequence. High availability is disabled from the cluster. As shown, vSphere HA is now turned off. Next, PowerChute disables vSphere cluster services. The VCLS VMs are powered off and then removed from the inventory. This is to allow the hosts to enter maintenance mode later on. PowerChute then begins shutting down VMs using the assigned VM prioritization groups. The lowest priority VMs are shut down first, and the highest priority VMs are shut down last. We can see the delay between shutting down each group of VMs. High priority VMs like the vCenter Server VM, Domain Controller or DNS Server VMs are left until last. PowerChute records an event to note that the vCenter server VM is being shut down. Logging into each ESXi host, we can see that all VMs are now gracefully shut down. PowerChute then runs the VMware reboot helper script to prepare the vSAN cluster for shutdown. Next, PowerChute places each host into maintenance mode. Since all nodes are being shut down, node data migration is selected as the vSAN data migration option. After the host enters maintenance mode, it is then gracefully shut down. Each host is placed into maintenance mode and shut down sequentially. When power is restored and the hosts are back up, PowerChute takes each host out of maintenance mode. It then runs the reboot helper script to recover the vSAN cluster. When the vSAN cluster is ready, PowerChute starts powering on the VMs per their assigned VM priority groups. In this case, the vCenter server VM will be powered on first. After all the VMs are powered on, PowerChute re-enables vSphere cluster services. Here we can see the VCLS VMs being redeployed and powered on. Lastly, PowerChute re-enables vSphere HA on the cluster. This concludes our technical demonstration. For more information, please visit apc.com/PCNS. Thank you for watching.